When working in a binomial distribution, calculating the mean, variance, and standard deviation is much simpler than working in just what I would call a regular probability distribution. You have these very straightforward formulas, so you just need to grab your calculator and you can have these done quite quickly. Let me just show you how quickly you can get these done. The formula for the mean is the mean equals n times p, and I'm going to show you how to identify your n and your p. Your variance is n times p times q. I'm going to show you how to identify q. And then your standard deviation would be the square root of whatever you find for your variance. So here's an example that you may see. Sometimes you may just see the problem given where they just tell you what n and p are and you don't need to pick them out of a word problem. But I thought I'd go ahead and just show you the most difficult case in which you have to pick the values out. So about 25% of babies born with a certain ailment fully recover. A hospital is caring for 6 babies born with this ailment. The random variable represents the number of babies that fully recover. Okay, so we know this is a binomial experiment because we have a situation in which there are a set number of trials. We have 6 babies. There's an ailment and there's a success or a failure. Either they do or they don't fully recover. Okay, and our probability of being born with the ailment is 25%. We know that about 25%. All right, so in this case, our P, our probability, is 25%. It's 0.25. Our N is 6. So we're given our N. And you'll always be given N. You'll also always be given P, all right? Now the only thing you'll generally have to calculate out of your problem is your Q, and Q is so easy to find. Q is just the complement of P, and the complement is something we learned back when we were first learning about probability. The complement is just the rest of the probability. Remember, probability always has to total up to 100% if we're talking in percentages, or 1 if we're talking in decimals. So we're talking in decimal now. I converted it to a decimal, or we can look at it up here in percentages. The rest of the percent, if we're already taking up 25%, is 75%. So the way you would find that mathematically would be 100% minus 25% leaves me with 75%. So that means Q is 75%, but I want to work in decimal form, so I'm going to make it 0.75 because that's what makes it easier to work with when I'm plugging it into my formula. Okay, so let's just say I had like a different number. Let's just go off on a tangent here for a second. Let's just say that P was given as 0.69 and I needed to find Q. Well, that's no big deal. I can do that. I can say Q equals 1 minus 0.69. So my Q equals 0.31. Because see, if you took this number and added it to this number, it would equal 1. So 0.69 plus 0.31 equals, or yeah, 0.69 plus 0.31 equals 1. I hear my dog. So let's put all this together and see how easy we can find the mean, variance, and standard deviation now that we have each of the components needed to plug into the formula. So the mean of this situation would be mean just equals n times p. So we take our n and we multiply it times p. So grab your calculator. So taking n, which in this case is 6, and multiplying times p. Whoop, p. I started to write in p again, and I know p. I don't need to use the variable. Let's see. N times p, which is 0.25. Let's see. I think I should put that in parentheses so it's a little neater there. So n, or mu, equals, the mean is 1.5. If you plug that in your calculator, you should get 6 times 0.25 should give you 1.5. So on average, we should see 1.5 babies fully recover out of every 6 births. So then our variance is going to equal n times p times q. So n times p times q. So we're going to say 6 times 0.25 times 0.75. So when we plug that into our calculator and work all of that out, we get 1.125. And last, we will get our standard deviation, which our standard deviation is just the square root of whatever we got by multiplying n times p times q. So we're going to take the square root of 1.125, and that value is 1.06. Now, I'm going to show you a little trick. If you have 1.125 already in your calculator and you don't know how to use that square root key, you can also use your exponent key. You can go 1.125 raised, and that's your exponent key. If you have an exponent key that looks like that, I don't know what your exponent key looks like, but most people have that little key right there for their exponent, to the 0.5. The exponent of 1/2 is the same thing as taking a square root. So those two things are the same thing. So if you raise 1.125 to the 1/2 power, you will also get 1.06. So that's just a little mathematical sorcery there that you can do and get the same thing. Or you can just use your square root key if you are very comfortable and know where that is. But some people have a hard time finding that if you're using one of those big graphing calculators. You have to go through several layers of keys to get there. So anyway, that's a little trick that I'm just sharing with you. So hopefully you can see how easy this is, and it helps you out for finding the mean, variance, and standard deviation of a binomial distribution.